Hi, so we're going to do a bit more integration. Now, if you remember in the last video, what we were looking at, integration by inspection or reverse chain rule. So what we were looking at, questions of this form. So k f dash of x, f of x to the power of n, k f dash of x over f of x, and k f dash of x e to the power of f of x. So we said these three forms were the forms to look out for. And these meant that we had a function that had been differentiated using the chain rule, so we could reverse those steps as we did in the previous video to reverse the chain rule. Okay, so sometimes called reverse chain rule, sometimes called integration by inspection. What I want to do is I'm going to go through these four examples with you again for this video, but this time we're going to use a different method called integration by substitution. Now you may think, what's the point in using a different method to do these same questions? Well, it may be that you prefer this other method, perfectly valid method to use, or it may actually, but the integration by substitution, which is what we're focusing on for this video, is a skill we need to have anyway. And questions like this provide a nice kind of easing into the method before we potentially look at more complex questions that involve using integration by substitution. So what we're going to do is we're going to go through these four again, and hopefully we'll get the same answers. So the first one we're going to have a go at is we are going to integrate 4x 3x squared plus 1 to the power of 5 dx. Okay. Now for integration by substitution, we need to pick part of our function to kind of replace with a different variable. Now, what we do when we have something of this form, if we were asked to integrate this, we'd be looking for what form it's in. We've got f of x to the power of n, and then a multiple of the derivative there. What we do is we choose the inner function to be the function that we replace. Okay, so in this case it'd be the 3x squared plus 1. So what I'm going to do is I'm just going to go over to the side of the page and I'm going to say, well, this inner function 3x squared plus 1 I'm going to call u. You can use any variable you want. I know some of you will want to use smiley face. It doesn't matter, but yeah, don't use smiley face. And then what we do with this is the same time every time we do this integration by substitution, we decide what function we're going to replace, unless we're told what to use in the question. And what we do is we differentiate it. So we get du dx. So differentiating this, we get 6x. Okay. Now if we look at the function we're trying to integrate, I can easily replace that 3x squared plus 1 just with u now. But the problem is I then have a function that involves x's and u's that I have to integrate with respect to x, which is a bit bleh. So what I do is I also rearrange this to make dx the subject, because then I can replace the dx with something else. Okay. Now if we rearrange this by multiplying both sides by dx and then dividing both sides by du, we get that dx equals 1 over 6x du. So I now have something that I can replace the 3x squared plus 1 with. I also have something I can replace the dx with as well. So that's what I'm going to do. I'm going to go back over here now, and that 4x, nothing really I can do with that at the moment. I can replace all of this though just with u, so 4x multiplied by u to the power of 5. And then the dx becomes 1 over 6x du. Now a moment ago I said, well, we don't want a function involving x's and u's that we have to integrate with respect to x. We also don't want a function involving x's and u's that we have to integrate with respect to u. But we can see when we make this substitution, the x's cancel. So we now end up with a function just in terms of u to integrate with respect to u. So just tidying up a little bit before we go to integrate it, the 4 over 6 becomes 2 over 3. And we still have the u to the power of 5 du. So now we end up with something that is far easier to integrate. It's just a simple polynomial. So I can pull out that 2/3 out to the front if I want to get that out of the way, because it's a factor of the whole function. So it boils down to me just integrating u to the power of 5 with respect to u. So it's going to be 2/3 multiplied by, and then here we're going to have u to the power of 6 over 6. I've integrated, so I now have my constant of integration. And tidying this up, I'm going to get 2 over 18, aren't we, which is 1 over 9. So we get 1 over 9 u to the power of 6 plus c. Now the function we had was in terms of x. My integral happens to be in terms of u, so we now just kind of replace u back with the 3x squared plus 1. So we end up with a 9th of 3x squared plus 1 to the power of 6, pardon me, plus c. Okay, and then we can see, if we go back to the piece of paper I used in the last video, that's exactly the same answer. Okay, so just 2 different methods. Now, as I said, if you really enjoyed the last video and had great fun with this, you might be thinking, well, I want to use that. That's fine. But you do need to be aware of this method because there are some functions that we can't integrate using this method that we can integrate using integration by a substitution. It's just that this is a nice lead in. Okay, so let's have another look at one of the ones that we integrated in the last video. Okay, so the next one we'll have a go at is we'll have a go at integrating 2x over x squared plus 1 all squared with respect to x. Okay, so same as last time, what we do is we call our inner function u. So u equals x squared plus 1. Okay, in terms of how I decided that was the inner function, if we just think back to the last video, I rearranged it into this form, didn't I? And I saw this is kind of my k f dash of x, and this is my f of x being raised to the power of n. So that's why the x squared plus 1 is my inner function. So same as last time, whenever you decide what your substitution is going to be, we now say differentiate it to get du dx. So du dx is 2x, and then I rearrange this to make dx the subject. So multiply both sides by dx, but divide both sides by 2x. Okay, and then we're going to get dx is 1 over 2x du. Okay, so now we're ready to make our substitutions. So we end up with 2x over u squared multiplied by, and then I can replace dx with 1 over 2x du. So it's kind of like when we were doing the last video when I said things start cancelling down, it's a sign we're on the right track. Similar kind of thing here, the 2x's cancel down. Okay, so what we end up with then is we end up just with the integral of 1 over u squared with respect to u. So if I were to integrate that now, I'd write that as u to the power of minus 2 du. So integrating that, I'm going to add 1 to the power, I'm going to divide by the new power. So we end up with minus u to the minus 1 plus c. And then we can just remember to replace u with x squared plus 1 at the end. And again, if we just go back to what we did last lesson, we can see that the answer we've got here is the same as what we had here at this point. We rearranged it a little bit last time, but it just shows that it's a different way of integrating the same function, using this time integration by substitution. Okay, so both of these ones were kind of polynomially ones. They were in that form. We didn't have kind of anything involving exponentials, logarithms, or anything like that. So what happens if we try and use this integration by substitution method for one like that? So let's try another one of our functions from last lesson. So this time we are going to integrate 6x over x squared plus 1 dx. In terms of picking what my substitution is going to be, if we look at the form of our function, last video we decided it was in this form k f dash of x over f of x. So our inner function is f of x, so it's going to be the x squared plus 1. So u equals x squared plus 1. So du dx is 2x this is the same substitution as the last example, isn't it? So then we're going to get dx is 1 over 2x du, just by multiplying both sides by dx and then dividing both sides by 2x. Okay, so now we're ready to make our substitutions. So we end up with 6x over u multiplied by 1 over 2x du. Again, we have that lovely situation where the x's are cancelling. The 6 divided by the 2 will give me 3. So I end up with 3 over u du. Okay, so I can take out that factor of 3 if I wanted. Get 1 over u du. So then we have 3 lots of, when we integrate 1 over u with respect to u, we get ln u plus c. And then we just remember to replace u back with x squared plus 1 plus c. And again, if we kind of see if that agrees with what we did in the last video, we can see yes it does. Okay, so one last one to have a look at, which was the exponentially one. Okay, so we're going to integrate 3x e to the power of x squared plus 1 with respect to x. So same as last time, if we think about the form of this, we've got k f dash of x e to the power of f of x. So this is my inner function. I think when I did these examples the last video, I liked x squared plus 1 being the inner function, didn't I? So we have u equals x squared plus 1. So we get du dx equals 2x. So dx equals, you should know by now, seeing as we've done it for the past 3 examples, 1 over 2x du. So we're ready to make our substitutions. So the 3x, nothing I can easily do with. E to the power of, and then this is u, multiplied by 1 over 2x du. Oh look, the x's cancel, yippee. So then we end up with the integral of 3 over 2 e to the u du. We can take the 3 over 2 out of the integral if we wish. So then we end up with 3 over 2. Integral of e to the u with respect to u is just e to the u plus c. Remember to undo the substitution if you like. Excuse me. And then I think I might sneeze again in a minute. If we compare that to what we did last lesson, yippee, all matches up. So we can see it's just a different way of was that all of it on? Yeah, different way of doing the same integral. So this way was kind of reverse chain rule. This way is spotting it still in that form, using that to identify a substitution, but then using integration by substitution, this method, to get to the same answer. Okay. Now another thing to be aware of is with integration by substitution, it's also can give you a little bit of a shortcut when you're doing a definite integral. So in your textbook, there's a really nice example and it is set out very nicely for you. If you have a look at this example here, so this is page 205 at the top, there's a couple of examples kind of in line with what I've just talked through, so it's well worth having a look at those, see if you can follow those, make sure you're happy with them. And then if you have a look at the bottom of the page, there's one here where we've got limits, and you can see that once you've integrated it with, and you've got your function in terms of u du, what you can actually do is then change the limits. So see if you can follow what's going on here, okay, where we have to change the limits. Once you've had a look at those and you're happy, what you should have done after the last video was work through this column, So this is on page 206. What I'd like you to do is I'd like you to use the integration by substitution method I've just gone through to try and get through these ones. Okay, so hopefully you will have done these kind of reverse chain rule the method from last video, and then this using integration by substitution, the method from this video. So have a go at those, and then also have a go at 3 and 4. So these are one with limits. So this is where you need to think about the example that's just on page 205. Okay, so hopefully that's useful. Hopefully that made sense. Same as last time. If there's anything whatsoever that you would that you're unsure of, if there's a question you struggle with, just drop me a message through the VLE or to my school email, and I'll get back to you as soon as I can. Okay, bye.